Before we start, Ray and I want to address something. So how many of you are familiar with the Java Champions program? How many of you have heard of this? Okay, about half. So the Java Champion program is an international recognition for people who have made an impactful contribution to the international Java community. And one of these persons is in this room. It's somebody who has dedicated lots of his spare time to developing all your favorite build tool. Well, I think of almost all of you, and the rest still has to discover. And this person is Robert. He was recently appointed a Java champion, so I think it's a good time to congratulate him now with a big applause. Woo! And without further ado, it's now up to Ray and Robert to entertain you. Enjoy.
All right, thank you. Congratulations.
Thank you very much.
Yeah, all right.
So we had to change this slide already.
Yeah.
We did it like 10 minutes ago. So.
I had to do it in secret before you see it. Okay. All right, so go ahead.
Go ahead. We have a lot to talk about. We even added some extra slides. So I'm Robert. I write some articles for the Java magazine for the LJAC. And that's Ray. Let's go fast. He works for Google.
Yeah.
So you see the shirts, it all explains it, right?
Wait a second. You have a Google shirt on.
You an LJAC. So let's start with confusion.
Yeah, we need to switch shirt later.
Yeah, no, not on stage.
So welcome to this session, and I'll give you a little background on how this came about, just very quickly. So I'm a Google Cloud developer advocate, so I do a lot of work around the Java stuff running on Google Cloud. And one of the first things that you will probably use when you try to use any cloud services are client libraries. So you need to include these client libraries. You have these dependencies. And about 3 years ago, we had a lot of trouble with dependency management. You can include two client libraries, and they may not work together. And we see all these errors. And what happened is every time I see one of these things, I ask Robert, like, Robert, help me with Maven. Like, what is wrong with this? Like, how do I fix this? And so what we're going to see is the progression in time from 2-3 years ago in the client libraries and what the experience was to how we fix everything. And we publish all the best practices now in a site called jlbp.dev. So this is Google's best practices for Java libraries. This is all the learnings that we have been applying. And we're going to go through many of them today as well.
JLBP, how do I remember that?
You can remember that as Java Library Best Practices.
Okay.
Yeah. We probably need to put a G in the front, but it was too late, so you got 4 letters. Yeah, and it's on the .dev domain name, so it's pretty cool. All right, cool. So let's see the code. So this is what happened before.
It's already red. So.
Yeah, it's already red, but that's not why it should be red. But so here's a example that I wrote up. It's very, very simple stuff. We just have 2 dependencies here. We have a translation API, so we're depending on the translate API here with the client library. We have a truth, so this is just something for testing to validate, the values in a nice way. And then I put this thing in a simple test so I can run it easily. And typically you probably put in the Java main, right? So in the main Java directory, but now I'm just in the test. And this is a simple test for running this app. I'm using a translation API, so I have to translate from one language to another. This is something written in Chinese. Anyone read Mandarin? Anyone? Yeah, there's one person. That's okay. What does it say? It doesn't really matter.
Otherwise, I'm going to start Dutch jokes, right?
Yeah, there you go.
Dan ga ik gewoon in het Nederlands over, geen probleem.
What?
Continue.
All right. So what we're going to do is to translate this from Chinese to English. This actually says, how are you? How are you? It's okay. You can trust me on that one. And then we are going to validate it with truth, and everything's simple, right? And IntelliJ doesn't complain. Maven is not complaining right now, so everything should work. We're writing in Java, so if it compiles, it should definitely work, right? So let's go ahead and run this test. I'm going to go ahead and run it. Run simple test. And let's see if I got everything here. Oh, interesting. What is that? No such meta error. How many people have seen this type of error before? Oh my God.
Recently, like, I know this happened like 15 years ago, but
still
now
happens.
It still happens.
Yeah. And so we see these we see these errors a lot. In fact, every time you see a no such method error, no such field error, no class def found error, no whatever error, it's most likely a dependency problem. And this is the thing that we're trying to go through today and see how we can resolve some of these things. So one of the things is that this dependency tree looks something like this, right? Dependency tree. So we can use the Maven dependency plugin, I guess.
Yeah.
So I can see the dependency tree, and for this simple test, that's all the dependency.
It doesn't fit on the screen on one.
Yeah.
Screen. So we should make it a little bit smaller.
Smaller. Yeah. So one of the things that we have to figure out is kind of like, where is this error happening and why is this happening, right? So so here we have some pointers. com.google.com. You all know what that is? Guava. That's right. So I think the first thing that we need to know is where this is happening, and then kind of guesstimate what is actually potentially causing the issue. Why isn't there a method here called check arguments in that particular class? So what do? We can do the dependency tree, and then let's look for Guava or something.
Let's look for Guava.
All right, so I'm gonna say dependency tree. I'm gonna zoom in a little bit here. Zoom in. Dependency tree, and then if you want to look for Guava, this is what I like to do. I just say grep, right? Guava. This is what we usually do. And then now look, there's only one Guava version. So
well,
fine, right?
what you see right here is the resolved dependency tree. So what you're actually looking for are conflicts of dependencies, right?
Yeah. So let me.
So there's this flag. You can say verbose.
Okay, so with the dependency tree, there's a flag I can use.
Yeah.
Okay, so I'm gonna say D.
Yes.
Is that right? Verbose is equal to true, or
yeah, you can do this, but you can also remove the is true part because this is exactly the same. So if you always have to type in Maven skip test is true, you can also remove the is true part.
Just do a skip test, right? That's what I usually do. Okay, good to know.
You do that all the time, right?
Yeah, I do that all the time.
Yeah. Right. Okay.
So here's the Guava tree. Then let me just zoom out a little bit. There's a lot of it.
Okay, but
so what am I seeing here?
Yes. So one of the you did a grab, right?
Yeah, I did a grab.
Because of that, the tree looks kind of weird.
Right. Yeah, because here you have Guava that depends on Guava, which doesn't make any sense.
So you only see the lines with Guava, where you actually want to see the path to that.
Okay.
Right. So what you can do is you can add includes.
Okay.
Yeah.
So I can do Maven dependency
Dependency tree. Yeah, I make always the same mistake.
The verbose,
yes,
right? Something like
verbose,
that.
Yes.
Yep. And then D
includes.
And what can I do here? I can do.
Yeah, you can say you can start with a group ID.
Okay.
Then you can combine it with artifact.
Guava, and then like Guava, like that.
Yeah.
And so what this will show me is the dependency tree of.
Yes. So now you have the path to those Guava dependencies.
I see. And we can also clearly see where all of these Guava dependencies are coming from, which is kind of nice.
Yeah.
And also, I think the more important part is this one, which is omitted for conflict. Okay, so whenever you have a dependency conflict, you see no such whatever found error. This is the first thing that I would do as well. Right. Yeah. So what is it saying here? This is saying that we have Guava. We're using Guava 19 here, and then there's some dependencies on Guava 28, which is really new. There's some dependency on Guava 26. How many people here have dependency problems with Guava before? Guava, yeah, a lot of people. Yeah. So this is what you get. If we don't see the version behind the scenes, and they are all being omitted for some reason, and now they are all using Guava 19. And so the newer code that's using Guava 21 and 28 is not able to code the API that's only present in the newer versions.
Right. So Guava has a bad reputation somehow because they keep changing signatures. It's not really that backwards compatible.
Right. Yeah.
So that's one of the reasons why you saw those missing methods or whatever. Because for some reason they decided, we don't use it anymore. Just remove it.
Yeah. But however, we know these issues now. This is one of the root cause of many of our issues. And now in Guava 21 and above, they are trying to keep all the backwards compatibility. We're going to talk a little bit more about that best practice as well, because it's better if you upgrade your library versions. You always try to keep it backwards compatible. So what happened here is that we have two versions of our dependencies, and we have to figure out what version to use. Now, why do we only get to pick one version?
Why just one? So what does the class path do in the end?
The Java class path?
Yes.
Yeah. Okay.
So it's all about the Java class path. And if you need to use a specific class, what it does, it just goes through all the jars. And the first one that the jar that contains this class file wins. So it doesn't make sense to have multiple versions of the same jar file on the class path. And Maven always picks the nearest one. And nearest means if you have a complete dependency tree, the direct dependencies are the first level. And if it's there, that's the one that's being picked. Otherwise, to the next level otherwise. Yeah?
So, and then if you have two of the same dependencies at the same level, then it's going to pick
The first one.
the first one.
Yeah.
And this is slightly different from, say, Gradle. In case of Gradle, they choose it differently, right?
Yes. So Gradle kind of understands versioning. And what they say is, we're just always picking the latest one.
Yeah.
It's just a different way to do that. And what we say is we pick up the nearest, which makes it a little bit fast because we're not comparing all those versions. We're just saying, okay, this is the first version we're hitting for this artifact. Let's go for that one.
Yeah, and I think that comparing versions can also be a little bit difficult because even if you pick the latest one may not be backwards compatible, right? So it's probably the best that you pick the version that you really want to use and you test against, right? But then on versioning, why can't Maven just pick the newest version or pick the most compatible version? That would be really nice.
Yes, but what is most compatible version? You just don't know. So that's why we say, if you really want to use a specific version, add it directly to your POM file.
Yeah.
That makes it level 1 nearest version. So yeah.
And for that reason, Maven also does not, like the version field, Maven does not understand the actual semantic around that.
No, in general it doesn't.
Yeah, so Maven does not understand the same verb, so there's no way for us to even figure this out. Even if it understood the same verb, the libraries may not actually implement all the best practices in Semver, and so there's no point in doing that either.
Right. So what you see is in Semver you say that the major version is allowed to be a breaking change. Well, in Maven we don't understand that. You just specify one, and that's the one that's being used.
Yeah. So how do I detect one of these issues early though? Like I don't want to see this issue with a conflict in dependency, just like when I'm running the app or when I'm running the test and trying to figure this out. What is the best way for us to kind of detect some of these things? Of course, I think doing the verbose thing is one way after the fact.
Afterwards, yes.
Yeah. But how can I do this up in front and early?
Yeah, so most of the time, if you think about requirements, band, or whatever, you're thinking about the Enforcer plugin. And the Enforcer plugin is one that has quite a lot of rules, and you can verify them at the beginning of your startup of your project. And there are some interesting rules that are, very useful in this case.
Okay.
Because what we want is, if we assume that everything is backwards compatible, you need something like require upper bound rule.
Okay, so let me go ahead and add this enforcer rule. I got a nice shortcut here.
Yeah.
So I'm using one of the latest version of the enforcer rule, and this enforcer rule will, run against your build and fail your build if you violate any of the rules, right?
Yes.
And so I think there are two rules that we can potentially use,
yes.
right? So what are these two rules again?
So the first one says that that's the most strict version, and this one says that all the versions of a specific dependency must be exactly the same through the whole tree. So through all the verbose tree you saw. So that's kind of hard, especially when the project is growing. So you can give it a try.
Okay, so I'm gonna add this enforcer rule here to my enforcer example.
Yeah.
Let me just show you the dependency tree right now, and maybe this will show you we have a lot of dependencies in here. We don't know exactly which one's having, these version incompatibilities. They're using different versions. And so I can do a build, I guess. I can do a build, or I can do Maven Invalidate. Validate should work, yeah. So let's see. Oh, look at that. Ah, interesting.
Yeah.
So here we go. So here's the Maven Invalidate with the enforcer rule. And we can see that there are a lot of these dependency version misalignments here. So this is JSON 2.7 and 2.85. Which one should we be using? We have to pick 19 and 123, another problem, and so on and so forth, right? So there's a lot of these issues that's kind of out there. But so there's a lot to resolve.
Exactly.
Yeah.
Yeah.
So what was the other one that you mentioned?
Require upper bound depth.
Require up and bound. Okay, so let's try this one. So this will, what would this one do?
So this one will verify all the versions for those specific artifacts, and it will check if you are using the latest of those.
Only the latest ones, right? So in this case, if you have 19 and 21, as long as you're resolved to 21, this will pass.
Yeah.
Right? So let's
So in
try
this case, Maven does understand Stammerer.
Ah, interesting. Okay.
Curse you!
Oh, what? What was that? Did you hear that? It is October 31st, so it is Halloween. Let me try that again. What happened? Wait.
Curse you!
What?
So this is something we added like 10 minutes ago, right?
Well, what is this? What happened?
So this is a Maven extension I wrote, and so at home, when every time my build breaks, I hear something like this.
Every single time.
Well, I don't hear it that often, you know.
Oh, wow.
That's fine.
That's amazing. If you want to learn more about this extension, it's a lot of fun. Come afterwards. It's a lot of fun to add in. So hopefully we don't hear this a lot today.
Well, I'm afraid we are.
You're afraid we are. Yeah. But the upper bounds, right? Think about it. If we're always requiring the latest version, then the latest version is not guaranteed to be backwards compatible. Then upper bound is may not actually be the right solution either. So upper bound only works if the higher version is backwards compatible. So we do have some best practices around this. Number one is that as you are creating a new version, you should make the transition easy, right? And you should have backward compatible APIs until you're ready to actually break. And in case you're wondering what this looks like, let me see here. Let me just go a new tab. Oh, new tab here. It is Halloween. Look at that.
Yeah.
Yeah. So I can go to glbp.dev, and this is where we have all of these rules. And we are just going through one of these. So every single one of these rules is going to help you, if you are creating a library, to reduce some of these dependency conflicts for your users. Okay. So let's see here. Let me go back to the slide. How do we resolve it? So we got these upper bound issues. We have this convergence issue. How do I get rid of these things?
Right. In this case, we need to pick a version.
Okay.
Yes.
Yep. So for all of these versions, if I'm using upper bound, then I need to say pick the 2.8 version.
Yeah. Exactly.
Okay. So how do I do that? I guess one way is to be able to do this as a direct dependency.
Yeah. You could do that, but
Okay.
in general, direct dependencies are used you're specifying them when your code is using them, and I think in this case you don't use them, right?
No.
No. So in that case, it's better to use dependency management.
Okay. Okay. So we can add the direct dependency, or we can exclude some of these things, but then we can also use dependency management.
So
as well.
exclusion might be a little bit dangerous because in the end, it does want to use those specific classes. So I would prefer dependency management.
I see. Yeah. So by exclusion, it will be something like this. Like if I have a conflicting version of Guava in one of these tree, I can just go ahead and exclude it. And now I'm going to be depending on the Guava version that's imported from another dependency tree in the same project, right? So yeah, so that could be dangerous. So what is dependency management? How does that work?
So dependency management is in the end a lookup table. So
Okay.
It's
Yeah.
and the funny thing is you can put anything in it. Yes?
Okay.
Yes. So what it does is if you have a specified direct dependency or transitive dependency, the first thing it will do, it will go into the dependency management and look if there is a specific version or some scope or whatever, and that is being used. So you have a way to globally define the versions and stuff for the rest of your project.
I see. So let me go ahead and open up a dependency management section here.
Yeah.
So it's a really, really easy way to kind of overwrite the versions of your transitive dependencies. So in this case, let me see here. This is example 3 dep management directory. So I'm gonna go there. So example 3, 3. Which one is this one? 3b dep management. So if I were to run this thing and with the Maven Invalidate, we're going to see the same dependency conflict arrows. Like,
you!
damn,
Of course,
another one.
we should be counting.
Yeah, I know. And now, if I were to use dependency management, so for example, in this case, Guava is the version that we have to kind of figure out what version to use, then we can go ahead and let me mute that for a second because I think there's a weird echo. So I can use the dependency management to manage the version of Guava that's been transitively dependent on. And we can do Maven Invalidate again. And then everything passes.
Exactly.
Yeah. So what happened then is that the transitive dependency that uses Guava will then look up this lookup table.
Yeah.
Yeah. And then you will override all the versions. Can I see the version override using using Maven Dependency Tree as well?
Give it a try.
Okay, so I should be able to do something like Maven Dependency Tree, verbose, and then we remember this includes com.google.guava and guava. So we should be able to see what happened here. And now you can see that version is now being managed to a different version through the dependency management section. Okay, very cool. So let's see, what else did we miss at this upper bound stuff as well? Let me go back here.
Well, there's one more thing I want to say about those dependency management. Like I said, it's just a lookup table.
Okay.
So you can add even non-existing dependencies inside of it.
Oh, what do you mean?
Yeah.
So like here in this lookup table, I can add a dependency here, and that's something
Ray.
Like, Ray dot
Tsang.
example dot group. Yeah.
Doesn't exist, right?
Doesn't exist. Yeah, definitely does not exist. Happy Halloween, something like that.
Yeah.
And I can give it a version. Does not exist. And there's no error.
No error.
Yeah. Okay.
Because this lookup table.
I see.
There's one danger in here. You can also specify snapshots. So that's the tricky part. You will detect them only when you're releasing stuff.
Oh, I see. Yeah. So do not have version on snapshots here.
No, absolutely not.
Yeah, got it. Yeah, very cool. So going back to the upper bound and stuff, right? Because we mentioned this a couple of times where upper bound versions may not actually work. So you use dependency management to pick the version. But then what if you just through the two dependency trees, subtrees, they cannot reconcile. Right, one needs to use the old version, another one needs to use a new version, and they just cannot operate with each of the other version. Especially if you're using, anyone here uses Hadoop by any chance, or like Spark or anything like that. Yeah. So in some of these systems, they will include a very old version of Guava in the system class path, and so whatever that you put in your jar or in your application that uses Guava will have a dependency conflict with the system class path. Right. So what's the proper way of dealing with these?
Well, I guess the answer is on the next slide. No.
Actually, it is.
Yes, of course.
I had to set you up well.
Yes. So in case there's no other solution possible, you can always shade. And shading means that you're bundling all those classes, and you're also going to relocate them, which means you give them a unique package. Because of that, there will be no other conflicts. So your internal code is using these relocated classes, and the other code are still using the original classes.
So you would, in your app, your Guava would be relocated to a different package, and then the system class path would still be the same, right? What about class loading?
Yeah, really good. Yes. So the other solution is class loaders. Sometimes that's the best solution. So could you imagine that, for instance, Maven, all the plugins should have exactly the same version of Guava? We're not using Guava, but suppose so. It would be kind of hard to maintain, of course. So with Maven, every plugin has its own class loader, so there's never a conflict between those plugins.
Yeah. So I think this is usually applicable if you're writing a runtime environment. So if you're like writing an app server or like Maven, like a container that runs other people's jars, make sure you class load properly so you don't have the class path dependency problems. Of course, you should not use any unstable APIs. Even if you're using the newest version of your the library, sometimes they actually annotate the API to be beta or unstable. But no one really checks these annotations, but you gotta be careful because if you depend on any non-stable APIs, eventually your users will be breaking as well. And finally, I think this one is especially important, which is that if you are maintaining a library, if you are sharing the library in your organization, if you make a non-breaking change, no, if you make a breaking change, is a major version change, then one of the things that you want to do is to make sure that they are not sharing the same package names. And so that if I depend on the newer version, I can depend on the old version at the same time. Yeah.
So the best example is probably Commons Lang. So there's a version of Commons Lang 1, 2, and 3. And what they did is they gave them all a unique artifact ID and also unique packages, because Command Lang is quite popular. And now it is possible to have a version of Command Lang 1, 2, and 3 on the class path. And because they have their own package, there's no collision possible.
Right. Yeah. Cool. So let's see example 3e. Let me see here. What is 3e? Let me see example 3e. Okay.
It says clash.
It says clash. Yeah. What is that? What is? What does it say? Clash already. That's too early to give away. But let's give away. Okay. So let's give it a try. So clash. So here we have another example here. We're using Firebase admin and pops up. Right. So we're just again using two different APIs that we have. And if I go into the clash, if I go into the test, we're going to see the simple test. This is just, oh, interesting. That's not the clash. 1 second. Where's the clash?
Again, going to translate.
Yeah, right. Yeah, no, that's the wrong one. So here is the clash. Oh, I can't find my, okay, so there it is. So this is just using our messaging system to send a message. So we're publishing a message, by the way. It says hello, and again, we implemented many of these best practices, right? So we have dependency management. We're managing one of these, the library versions, and we have no conflicts in terms of enforcement. So the versions we're using the upper bound. We're using all these enforcer rules, and it seems to be working pretty well. Yeah. However, if I were to try to run it again, let me see here. Yeah. Let me see here. I'm gonna run it from the IDE. This way, yeah, there you go. And we, once again, have errors. So I applied all of these practices. I'm doing the validation. I'm doing everything properly. So, for example, even if I go back to Clash, if I do Maven just validate, right? The enforcer rule is gonna kick in, and I think it's gonna be. Oh wait, what?
That's the wrong face.
Is it validate? I can't spell today. Yeah. And yeah, so in this case, everything works. But yet, my application is still failing to run.
Yeah.
Now, what happened here?
So this one, it's again Guava. You really need to talk about those.
Yeah, that is Guava again. Yeah. So this one is particularly hard to understand, actually. Because what happened is, if we run the dependency tree again, dependency tree with the verbose, and looking for Guava, what do we see? We see that all of these are omitted for conflict, and this is fine. However, this is where I still like to use grep, because if I do a pipe with a grep, let me see here.
I think you can also do it with a...
Yeah, can you?
Yeah, I think so.
Okay, so let's see. Let's see if we can do it. So here we see Guava again. So not only do we see the regular Guava, here's the Guava artifact, but here's another one. It's called Guava JTK5. Okay. So what happened is...
That's old.
Yeah. So what happened is it didn't follow the previous practice, which is that these two artifacts, or actually it's the reverse of the other practice, which is that these two artifacts actually have the same package names, and they have the same classes. And remember what Robert said about the class path, one of the first thing that the Java class path find is going to win.
Yeah.
Right? So this one is really hard to find. Like I don't even know how to look for it unless if I knew exactly why there are two artifact IDs here for the same classes. You should never do this, by the way. Yeah.
No. But now that we discovered this, there seems to be some kind of duplicate classes, right?
That's correct. Yeah.
So and we somehow want to enforce there are no duplicate classes.
So is there an enforcer rule for that as well?
You've got it right.
Okay. Yes. So what is that? What is that rule? What is the thing I should be using?
Well, you can Google for it.
Yeah. What is it called? Wow, this thing is really useful. So what do I search for?
Ban duplicate classes.
Ban duplicate classes. With Maven, just to be specific. Okay, extra enforcer rules.
You've already clicked on that link, right?
Okay, so what does this do?
Okay, so this one is not maintained by the Apache Maven team, but this is one maintained by Mojo House.
Okay.
They also have a lot of plugins and also their own set of enforcer rules.
Okay.
That also means that you can write your own enforcer rules if you really want to. There's an API, you can implement it, and that's what you can do.
Okay.
So what you need to do is you add this dependency to the Maven Enforcer plugin, because that's the jar file that contains these specific rules.
Okay. Let me see. Let me make sure I have the right one opened. Where is it? Right here. Oh shoot. Sorry, it's a small screen. So in this enforcer rule, I have.
Full screen, come on.
Well, you're looking at the wrong way. All right, so here's the dependency. So I have the enforcer rules.
Exactly.
And then I need to add the rule to bend it. Yeah. So how does that work? So I need to add it in the.
Just like everybody,
execution.
just copy paste.
Okay, yeah, here we go. Gonna copy and paste the whole thing. All right, so here's the execution, and that's it, right?
Yeah, you can fine tune it because I don't think you are using com.xyz.
Yeah. So these classes, I don't have them, so I don't have to ignore them.
No.
And then if I were to run this again, Maven Validate, right? And this will hopefully tell me what's going on. There we go. Very nice. So it actually found all the classes that's being duplicated between these two packages, which is literally everything. However, oh my goodness. All right, one second. Wait, hold on a second. Oh, I found it. But however, at the very top, it does tell you which two of these packages, which two of the artifacts are actually conflicting.
Maybe we should put it in the bottom.
Yeah, that's a good idea.
Okay.
Yeah,
So-
we need to go back and fix this.
So somebody can write a pull request for that, I guess.
Yeah.
It shouldn't be too hard.
Yeah, definitely. All right, cool. So let's see here. One of the another really hard thing to look at is we have this other example 3a. Let me go back to 3a. This is another really hard to find examples, which is called it's not 3a. Sorry, it's called actually 3c. It's called misalignment. Okay, so here we have yet again another very simple test with another pops up client library version 0.8. So as you can see, I'm progressing in time. I'm going back to the very old version to a newer version, and we're discovering different issues. And in this case, we're using 0.8 and blah, blah. And we are using dependency management to manage all the dependencies. And if I go down, we had, again, we got enforcer rules. And maybe we're banning the duplicate dependencies. Everything is there to work right now. So for example, if I don't have this, if I excluded this dependency management, then I'm going to see from the enforcer rule that I'm not using the latest version. And so I'm going to go ahead and use the latest version 1.10.1. And then, of course, if I were to run this test again, let me see here, it's under Maven test. And if I were to run this test, right, again, we follow the best practices. However, this test will again fail. However, this time it's not in Guava anymore, but it's in gRPC, which is something, also made by Google. Anyways, so... But why? Why is this happening? Robert,
Really
this is killing me.
To say these kind of things about Google.
Yeah, no, but this is killing me.
Yes, yes.
I'm running all of these things, I'm applying all these rules, but this is still happening.
So not enough rules.
Not enough rules, yeah,
Okay.
exactly, yeah. So what happened here, this is also very difficult to find.
Let's go again for the dependency tree and see if there are some weird things happening.
Okay, so let me do the tree. And not Guava this time. I'm going to look for gRPC. Okay, so I'm going to look for gRPC, and this one is particularly interesting. Yeah. Again, if I just only look for one artifact, I'm not going to see the issue. But the real issue here is that you can see maybe here. This is gRPC put above 1.10, and then there's 1.0.1 that's omitted. That's fine. However, this version was not omitted, right? So for example, here I'm using 1.10, and for some reason, some other very tightly coupled dependency is actually not up to date, okay? But in the whole tree, these are all upper bound. Yeah. In the whole tree, these are all of the newest version, but what's not communicated is their intent dependency of versions, okay? So so this one is very hard.
This one is hard to find. Yeah. But again, there is a solution for it.
Okay.
And that's what we call a BOM file.
Okay.
So that stands for bill of material. Okay. And what you can do is with a BOM file, you can sum up all the dependencies that should have exactly the same version.
Yeah. So with the BOM file, it's really just a dependency management section that you can import into your existing project so that you can override all the transitive dependencies. And because what actually happened behind the scenes is that something like this. right? So gRPC O and gRPC core is using 1.0.1, and the gRPC stub in this case is using 1.10.1. They are all of the newest version, but they don't communicate with each other well. There's a dependency misalignment. This is what we call it. And one of the easiest way is to produce a BOM, right? In this case, there's a gRPC BOM, which has a dependency management version in there. And then we can overwrite all the transitive dependencies from here. This is one of the easiest way to fix this issue.
Yes.
Yeah.
So it's a little bit tricky to define it in your own POM file because you have to add some two magic elements extra. So the first one is the type.
Okay, let me go back
because
to...
by default, it's of course a jar, but in this case, we're not looking for a jar, but we're looking for a POM.
Okay.
So that's the one we have to specify. And the other one is the scope we need to specify, and that's import.
Okay, yeah, so it's right here.
Yes, exactly. So this is the way how you add a BOM file to your project. And from that moment on, all the versions for io.grpc are exactly the same.
Yep. And similarly for protobuf, we also have many different modules of protobuf. They all have to use the same version between these modules. Otherwise, the modules cannot talk to each other either. So one of the best practices that we have also established is that for any multi-module projects that we have, we need to produce the BOM, right? So that we can allow you to be able to use the right version of the same modules from the same modules with the right version. So very happily to say that we have now gRPC, Guava, and like protobuf, everything that we got, we have a BOM that we can use. And what does that BOM actually look like? Maybe we can just open an example.
Yeah, sure.
Show? Yeah. So let me just find a gRPC BOM on Maven somewhere. Oh, I do have this queued up. Okay, so you can produce this yourself, especially if you have internet. Oh, they're right here. Yeah. Then you can see what it looks like. Yeah. So I'm gonna just go to files and we can see what a BOM looks like. So it's just got first of all the packaging is special, right? Packaging is it's actually a POM.
Yes.
Yeah. And then there's the dependency management section. And here we only list out the sub-modules in gRPC.
Yeah.
Yeah.
So only the one that needs to be aligned.
Now, wait a second. So if gRPC uses Guava, should I be managing the Guava version here too? Because then I will solve a lot of other people's issues.
No, you should not do that because you're...
Why?
In the end, there is an ordering thing about how you specify the BOM files.
Okay.
So you should only specify those that needs to be aligned and leave it the rest up to the POM file of your own project.
Got it. So only specify the ones that's in direct modules and never specify the transitive dependencies here. Yeah. Okay. Very cool. So let's go back to the slides. I think we're almost out of time, right? We have until 12:10. Yeah.
We don't need to lunch. Oh, sorry. Yes, we have a question actually. Yes.
Yeah, question. Go for it.
Yes. So what you used to do in the past is you have this property like spring.version and you added a whole list of these dependencies using exactly the same property. And this is, now you just have to add this one dependency management fragment inside of it, and then you're done. So this is really best practice, and actually Maven should also have a BOM file. We don't do that.
Yeah, you should, yeah. Because you could very easily include the wrong Maven dependencies as well.
They should always be in sync.
Yeah. Another really useful technique that gRPC has implemented is that they use version range. But in general, version range is bad, right?
Yeah.
But they do strict over version range. So what that means is that if you happen to depend on a version of a dependency that doesn't align with what you actually want, then Maven will fail, right? You hear that sound, and then and you know exactly what happens. It'll tell you what version you need to use. Okay. Now, if all things fail, if some of these issues are really, really hard to find, if all things fails, we actually have created another enforcer rule. This is great, yeah. So we customized, we created our own enforcer rule called the linkage checker. So this enforcer rule will actually go through your classes and your application code. Is going to do static analysis to go through all of the code trees to make sure that everything you are trying to use and everything other people is trying to use in your dependency tree actually resolve to a valid signature. So you can do a static analysis on the code to prevent a lot of things from happening in the first place. and then you can add to this in addition to all of the other enforcer rules that you have to help you to identify potential issues before you even execute. Because having these runtime errors, these are some of the most troublesome things to find in a runtime environment. Okay, so I don't know. Let's see here. Yeah. So let's go back to just go back to one of the last slides here. So one of the last issue is what we call the flattening issue. So so be careful. This is one last thing I want to talk about. Be very careful. Be very, very careful. Because if I have a library that uses dependency management to manage all of my dependencies, right? And then if Robert uses my library, what version of these transitive dependencies will Robert see? Okay, that's a very interesting question. So he either sees the versions I have dependency managed, or he sees the versions I have not as if I didn't use dependency management. And what he will see is the versions that didn't get dependency managed. Okay. So if you're creating a library, if you're using dependency management, it's great. Everything will compile. But when somebody else depends on you, all hell will break loose. And this is where you also need to provide them with a bomb to manage some of these dependencies as well.
Yes, and then you call me and...
Yeah, and this is where I call Robert again. So we have a little patch here called Flatten plugin. I have a little Flatten plugin patch that will help you to resolve some of these issues. It's been there for like half a year now. So if you want to see how this works and if you want to see this to be merged, please go to the pull request and
click on it.
Yeah, and click on like.
So everybody go to this. You should have a QR code or something like that.
Yeah.
But there's this like button. It already has 4.
Yeah.
So I hope by the end of the day it should be like 104.
Exactly. So this is the one of the hardest issues that we found so far. Okay. Yeah. So I think that's pretty much all we have time for. So let me go back to this one and yeah. So Robert, who here uses Maven? Wow. Now, Robert, how many contributors do you have for Maven?
Contributors.
What does that mean?
Okay, so contributors are people like you that provide patches and etc.
Yeah.
That can be quite a lot, but I think what you're actually asking are the committers. So that's the people that have access to repositories and accept pull requests. It's not that much actually. As this we see here, it's using by a lot of projects. But we're only maintaining it like 5 to 10 active committers. Yeah. And these are people that are not being paid for it. So there's no company behind Apache Maven. So we do it in our spare time, evenings, weekends sometimes. And it's kind of amazing that Maven is still doing great like this.
Yeah.
But we still could use a lot of help to improve it. We have real ambitions for Maven 4 and even Maven 5, and we could use some help. So if you are interested, what we did is we introduced a label, a tag. It's called Up for Grabs. And I'm not sure you don't have a link to that, right?
No.
We will share it. Up for Grabs is those are open issues, which should be easy to solve. Most of the time they're not related to Maven itself. It's just a Java puzzle, but it gives you a way to get familiar with the process of open source contributions. So I will put it on Twitter and have a look at it. And every now and then we have a look at new, fresh items that we are looking for to be contributed for.
Awesome.
Yeah.
Cool. And if you want to learn more about the best practices, you can go to jlbp.dev. Everything that we talk about plus more is fairly detailed documented there. So thank you so much for your time and thanks for being here.
Yes.
Great. Thank you.